This scene from Hancock takes the concept of conservation of momentum and really illustrates the idea that in a lot of superhero movies, when superpowers come into play, conservation of momentum and Newton's third law seem to take a holiday. Because what he does in the scene is he takes Walter, a gray whale who's 36,000 kilogram mass, has a mass of 36,000 kilograms, and he throws him with tremendous force out into the ocean. And what we're going to do is calculate, in reality, what velocity of recoil would Hancock really experience if the principles of physics in the world as we know it were to be upheld.
This is Walter, the gray whale. Everybody remembers him, stuck on the beach north of Zuma. Along comes Hancock.
Hancock!
I don't even remember that.
Greenpeace does. Walter does.
Here's the thing. Basically, what has to happen is the momentum of Hancock plus Walter before the toss equals 0. It has to equal their combined momentum after the toss. So, we write that out in our momentum, remember, is mass times velocity. So the mass times velocity of Walter before plus the mass of Hancock times the velocity of Hancock before the collision must equal their combined mass and velocity after, where direction matters. Negative cancels positive, so they have to add up to 0. So you have 0 total momentum has to equal the combined final momentum. Now, here's the little example of that. If you shoot this guy here, this little clowny guy, out of the cannon, and you shoot him, it starts from rest, you shoot him at 15 meters per second, and he's 100 kilograms, you're going to have 1,500 kilogram meter per second of momentum that way, which means that this has to go backwards. At what speed would you say? 3 meters per second, because momentum has to be conserved. The 1,500 that way has to equal the 1,500 that way. So we're going to apply the same thing to Hancock and Walter. Now we're going to do it. First, we got to estimate how fast Walter was moving when he left Hancock's hand. And I timed it with the stopwatch. It took him 5 seconds to hit the boat. And I kind of did some, estimating visually and looking at the water and the perspective. And I figured he was about 600 meters away. So that means he was tossed Walter with an initial speed off of his hand of 120 meters per second. It's a pretty good toss. It's a pretty good speed for a whale. And what I did then was plugged it back into the conservation of momentum equation, remembering that Walter has a mass of 36,000 kilograms. Hancock has a mass of 80 kilograms, popped it in there, and did his recoil speed. It's 54,000 meters per second. Hancock could throw himself all the way to the moon if he could do that. Of course, the problem being if he was moving at that speed through the atmosphere, he would burn up due to friction or collisions with air molecules. But that's another story.